Hi, my name is Medallo, BSED Science 2, a student in Liceo de Masbate. In this video, I am going to discuss esters. Esters are chemical compounds that are formed when an alcohol and an acid is combined and water is removed. What distinguishes esters from other chemical compounds is its pleasant smell, which often described as sweet or fruity. As a result, they are commonly found in perfume and food flavorings. In addition, these chemical compounds is volatile, means they evaporate easily. How to make an ester? In order to make an ester, we have to use carboxylic acid and alcohol. We also need an acid catalyst to speed up the reaction. We normally use concentrated sulfuric acid. When they combine, the carboxylic acid loses its OH group, and the alcohol loses the hydrogen from its OH group. And together these three atoms form a water molecule, which we call the byproduct of the reaction.
So first thing I need to do is add our ethanol, which is 15 mils. So we add that into our round bottom flask. We then now need to add our glacial acetic acid. So we're adding 20 mils of glacial acetic acid. And lastly, we're going to add our catalyst, or our sulfuric acid, which is 1 mil. Now, before we actually set it up, for safety reasons, we have to add some boiling chips as well. Now, the reason why we heat it is to speed up the reaction. Reaction setup is ready to go. So our reaction has been refluxing for 45 minutes. We've just turned off the heat and lifted it up out of the water bath for it to cool down to actually do the next step. So because we have so many different components still in our reaction mixture, we actually want to isolate our product. And to do that, we're going to add some water and shake. Release pressure frequently. So then, take the stopper off. And what you'll be able to see are two layers. We have a bottom layer and a top layer. And we'll just slowly run off the bottom layer. There we go. And that, okay, so the next step is so we're just adding about 5 mils. And again, shake. However, there may still be some traces of water in there, chloride. The amount we add depends on how much water we have. So we add enough so that when we swirl it, the calcium chloride moves freely around. If there was water still in there, what happens is the calcium chloride will react with the water and it'll clump and stick to the bottom. So we've just finished removing the water from our product, and the next step is to purify our product into a round bottom flask, and taking care not to include any of our calcium chloride that we added to dry the product. Different components. Our clamp tightly hooked onto our round bottom flask here. We've got a thermometer here with the thermometer tip just at the junction where it crosses over here. Our condenser, which is the same condenser we use for our reflux, but instead it's now horizontal instead of vertical. And then we've got a clean conical flask that's in an ice bath over here. Basically, what happens is, as the reaction heats up, our product will boil. Our product has a boiling point of 77 degrees. It will boil first and produce vapors. The vapors will rise up to this point. The condenser, water running through it, with the solution condenser vapors back into solution. It will run down here and it'll be collected. So to begin with, we just need to turn our water on, the temperature, and let it distill. So what we're going to do is only collect the fraction that is below 80 degrees, and that is what we know is our product. So our distillation's finished and we've just turned off the heat. All we have to do is just work out or measure how much of the product we made to a measuring cylinder to work out the volume. About 17.5 mils.